Hello and welcome back to Compiler Programming. Today I'm going to continue working on our userland negate implementation, which is basically the topic of the last couple of videos, and I'm going to skip the bitwise stuff for now because it's not really very different from what we already have with plus and other operators. In fact, I don't even need this should be bitwise and this should be bitwise OR. So let's actually fix that. And bitwise OR can be replaced with sum for this particular case at least. Like it's not generally the same as the sum, but for this one it is because they don't intersect. So I don't really need that one as well either. But anyhow, the topic for today will be something hopefully very fast, but we will see because there are some things to consider, and this is named return values. To clarify what it means, it's basically done here where I have an argument of type X, right? And I have a result, but besides the type, result also specifies the name that will be used for it. This allows me to explicitly return it here, which can be handy for situations where we do something in inline assembly or other things, and we want to be able to sort of get that raw value and do stuff around it. I'm not going into details about the rest of the stuff that's going here. I actually updated it slightly from the last time I looked at this code because I figured out how to remove some requirements like this matching on upper end and return type. I figured out that I could just I could simplify this, but we will look at this later when we actually implement this stuff. For now, let's get going with the named return types. Okay, I think I actually have a to do here somewhere, or fix me. Yeah, so this is a perfect candidate to actually fix this stuff. So let's get going. We will break this test first. Okay, and I'm gonna do a 64 here, but the inline machine code bytes actually doesn't return anything, so we have to explicitly say that we are valid. This will be a return or result. I shouldn't call it return because return is a keyword. So result, and we are going to do something like this. Now, another version of this would be to allow to kind of implicitly create a named thing for result. Like we could say that at result is whatever is this variable. It can be at return, but the problem with that option is that I will later want to add multiple return values. So this would be, I don't know, foo is S32, and then it would be nice to be able to access them that way instead of just a single one. Okay, so let's get back to this, and we will say result. So this stuff should work, should type check, and everything should be okay. So let's just try to run this and see what explodes and where. Okay, it thinks that we have multiple return values. That is actually not the case, but the reason it thinks so is because it expects a single identifier in here rather than a certain kind of expression. So let's get back to the code, and it would be here. We can look for this message and look at what we want to do with it. Okay, so this is how it looks like right now, and I need to change the way this works. So where are we dealing with the arguments? Let me quickly look. Yeah. So basically, it will look very similar to how arguments look like. And so we can copy that part. If it's not 0, so actually we can say if it is 0, then we do this. Otherwise, we try to split them up. Okay, so we split argue, our context, match argument. Yeah. Okay. Let's try to just do that, I guess. I think that's not gonna do what we want, but we'll see in a second. Token match argument. If we couldn't match, then we return 0. This is a check for the literal stuff, but for the return types, literal actually means something different. Yeah, I think we'll need to change things around a bit, but let's continue. Okay, and this is the return type, descriptor return type. Okay. Okay. So we have value and we have define value. Okay, so that's actually fine. This is what we want. And return values can be named. Okay, so if that is like this, and we define it, and we also need to, I guess, do the following. Arg value. Okay, I will not do this stuff. I'm not sure what this was exactly doing, but we'll see. If our tests fail, we will know that. Arg value and descriptor. Function return descriptor. Yeah. So this is a bit tricky because this function, if I'm not mistaken, it actually, yeah, it changes the descriptor to return the right thing. And that means that we actually need to do slightly different setup where we define whatever is in here. So descriptor function returns something like that. Yeah. So we have a similar one for internal purposes. Internally, there is also a value that can be looked up in scope for the return types, and the reason this is necessary is for inline functions, because when you do sort of an explicit return inside of an inline function, you need to know that this is not actually a return, this is just a jump, and this is used there for resolving that thing. You can take a look in the commit history in GitHub if you're interested about this stuff. You will see commit there about inline and returns and jumps and so on. Okay. So this seems reasonable. The only thing I'm not sure about now is token match argument. I think it will not do what we want it to do. So how does it work? It goes here, it tries to split an operator. If it finds the colon, then it will match the descriptor type. Otherwise, it parses a constant expression, and as the value, it will get that type. Okay. I mean, this is not exactly what we want, but I think we could make it work. So if we don't have a name, so this actually will be correct regardless, I think. So let's just for now do it this way. So if it has a name, then we do that. Otherwise, we will get the type as the value. Okay, assert assert descriptor arg value descriptor is descriptor type. Yeah. So if we got back the type, then everything is fine. I can do here to do user error. Okay, I got that. And we want to unwrap that descriptor. So that would be descriptor star return descriptor is going to be operand immediate memory as descriptor and arg value arg operand arg value operand like that. And this what is going to be here. Okay, that even builds, but I have no idea if it will do anything remotely like what we want. Let's try it out. That does not look promising. Something is crashing really badly. Let me take a quick look before I jump into debugging. I guess I don't see anything directly terrible, so let's just try it out. Which test is failing? So, interestingly enough, the actual test works. So now it is this stuff that is problematic. So let's break in here. Okay, we don't even get there. That is very interesting. Let me recheck what happens in token match argument. Okay, let me bookmark here as well. Okay, so if we didn't find this stuff, then we just do parse constant expression and we have a name that is empty and the value is the value. Okay, let's get back here, I guess, and oh yeah, And this is copy paste error that I already see. And the problem here is I need to go through the return types rather than arguments. Return types, return types. Yes. Okay. Well, let's try that again, shall we? Okay, which test are we... Okay, now we are failing in this test. That's fine. What is the problem? The problem is the function... Come on. Show me. Okay, that's very unhelpful. Okay. Function flags none. Yeah, it has very much empty returns. And where are we coming from? We are coming from match argument. Argument, next argument value. Ooh. Yeah. Okay, so let's... This is actually not what we want to be doing, so we're gonna, for now, just inline this into where we want it to be, or create a second one that is actually that's what we want. So token match return type. Okay, this is fine, fine. Okay. It's an identifier, that's fine. We get the descriptor. And here actually it should be like this now. I can even simplify this a bit. So actually, no, let's not simplify it unnecessarily. Okay, match type. If not type, then go here. And if descriptor is any. Okay. Here we would then put this function return descriptor. Function return descriptor, yeah. That seems fine. And here would basically be the same, I guess. Okay, let's leak a bit of memory and make it nicer to work with. So allocating, this is gonna be empty. Say arg name is this stuff. So we store the name if we find it on the left hand side of the column. And otherwise, we can do, yeah, we can do arg value is, so like this, we match type on the whole thing, and then we do the same thing here. Function type descriptor. Yeah, That seems reasonable. So we try to find the name. If we found it, then everything is great. We put that name in where it's supposed to be. And here we actually create a value that is going to be used in here. That means that we can now remove the return descriptor call from here, and it becomes a bit cleaner. So token match return type. Now, one thing that we need to take care of is this error message for not supporting multiple return types. So let's do it right now. I is 0. We can do 4. I plus plus. And here we say if I is not 0 or more than 0, then we again error out and say that everything is terrible. Can I copy from somewhere? Yeah, that seems reasonable. We need to say that we do not support multiple return types. I can even take a look at, I can't anymore on the message, but that's fine. Multiple return types are not supported at the moment. Okay. That is fine. Source range, well, I can do return types source range. Okay. What are you unhappy about? You are unhappy about that you allocator star to context. Do you get context? Okay, you do. From void to value star. Yeah. That is because this function actually modifies the function descriptor. So we can do it like this: is function returns. I'm also not sure about the descriptor any, so let's remove this and see if it causes any trouble. That means that we can move this out here, and we can probably move this out here as well, and say that this is 0. Actually, like this should be fine. You are complaining about return type? Okay, so now that should be better. Let's actually step in here and see what's going on. So this is the first test where we actually do have the name for this. So this should match, everything is fine. Did we get the type descriptor? We did. Great. We allocate this. Why is this allocated anyway? This doesn't make a lot of sense. Yeah, this makes no sense. This should be returning value. Arc. Oops, I'm actually, I did it the wrong function. That's not great actually. Let me grab this version. Then we will undo a lot of stuff. I think this is actually fine. Okay. Is this correct? Match argument. Are you still doing the right thing? No, you're not. So that's actually not correct. I screwed it up much earlier than that. Okay, so this is match argument, and this is supposed to be match return type. Okay. Cannot convert. Okay, that's why it was 0. Well, that's not great. Let's just return arg. Okay, and that would be dot. Okay, that's fine. But let's also change this one as well. Ideally, I should not do refactoring in the middle of the work, but it's fine. This is not something that is very complicated, hopefully. Just some arrows to yeah, this looks way nicer without dynamic memory allocation. This is also completely unnecessary. Okay. Arg. 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 Missed a few. Yeah, we cannot get empty one anyway. So a few more arrows to remove. I'm really looking forward to not doing that when this language is in a better state and I can start actually using it. Okay. Is that it? No, we also need to say match return type here. No, not here. Here. This has not been the smoothest ride, I have to say, but it's fine. That happens from time to time. Actually, let's run it here. Okay, we got to the right function. We got from the right tests? Did we get from the right place as well? Yes, we have it from the return types. Okay, that is nice. So let's get back here and see what's going on. We got here, we got here. We got the type descriptor. We get the value. Let's verify that. Arg value. Yeah, it has correct descriptor. It has correct operand. So we are in a register, which is correct. This is how we return an S64 value in this ABI. So that seems reasonable. We have a name. We define that name. Yeah. We could actually use the arg.value here instead of this stuff, but it's fine. Okay, we good more. We don't have any arguments. And yeah, I guess we can just try to run further and see how it goes. So this test actually passed, everything is fine. Now the question is, will all the other tests pass? Let's try it out. And we are in infinite loop. Where are we infinite looping? That is not very good place to break. So are we actually infinite looping? We are. Where does that happen? So this is the third test in user error. Okay. What's going on in the third test in the user error? Should report when encountering valid pointer type. This is kind of a strange place to infinite loop, but it is correct. So it really doesn't like this thing. Did I like screwed up something after all in the way I changed this? So let's verify. We have token match args. So this just changes the arrow to dot. That seems pretty reasonable. This we don't really care. It shouldn't affect how we are doing things. And here, while it done, split next. Argument. I guess I know what the problem is here. So we lost this error check, and this is where the problem comes from. And this might be the reason why it was in. Actually, no, we can figure this out. So I changed the way I deal with errors actually. And now whenever I add an error like this, it actually marks the whole program as incorrect, right? So it changes this variable as also tested in all the functions. And that means that wherever I want, I can do this check and do whatever I want to do. In this particular case, what I can do is to stop iteration if argument is incorrect. So in here, I can say something along the lines of mass on error, context result, return 0. Master results, we need to do this. Actually, no, we need the opposite. We need to do this. I think this should do the same thing as what the previous check was doing, but we'll see. And it is. Okay, that is basically all the feature. It took a bit more than I wish it did. We can take a look at changes. We just did it, so it seems pretty reasonable. So yeah, that is one more thing of the list. I can go here and do a check mark and feel pretty good about it. And that is all for today. Hopefully next time we will go more into this issue, and little by little we'll actually make it possible to implement operators in userland rather than in compiler. For today, that is all. Thank you very much for watching, and hopefully see you next time.